What's up? What's up? What's up? There's three of y'all out there. Sorry I wasn't on yesterday. I was just not feeling real well. Kind of blah today too. Thank you, Jad, for putting my starting out with my question. With questions? Anybody got questions? Let me finish cleaning my glasses here. What's up, Jad? I have an overwhelming feeling there's not going to be a lot of questions. There wasn't a last stream. So, yeah, I didn't do one yesterday because I was just kind of feeling not all that great. Still pretty blah today, so. Not much really going on. All right, so Mary's got a ton of questions. Start firing away, Mary. That's geometry, so that's right in front of me. Dad, leave them alone. It's just a typo. Probably on their phone. Victim to autocorrect. I know I am a victim multiple times of autocorrect because I can't spell. Oh. So I think there's only going to be one more week of schoolwork. That's the rumor I've heard, so. At least for our school. If that's the case, there's probably just 1 week left to stream it for me. Bring the iPad in here? Gotcha. I'm waiting for Mary to ask questions here. Mary says she's got tons of questions. Huh? Um, this week, question 1. All right. Yeah, the Kodacam's not going to work. I forgot to charge it.
Stop.
Okay, so question 1. First off, this week, what I'm looking for is finding the equations of lines that are parallel and perpendicular. So you have to know the relationship between parallel and perpendicular. So let's just start. I gave you the equation y equals 2/3 x plus 1. So this is the line we want to be parallel to and the line we want to be perpendicular to. But we want the other line to go through point P, which is 3, 0. Okay, so the first thing we need to know is the relationship between parallel and perpendicular. Well, parallel means they have the exact same slope. So we have to remember from the slope-intercept form, because this is written in slope-intercept form, what the slope is. Y equals mx plus b. So the slope is my m. Whatever number's in front, or the coefficient, what we call in math, is in front of the x, with the sign is the slope. So in this case, my slope is 2/3. So this line here, y equals 2/3 x plus 1, has a slope of 2/3. So for a parallel slope, they're going to be the same. So my parallel, this is a symbol in math for parallel. Parallel slope, m, because we use m for slope, is going to be 2/3. That means every single line that exists that has a slope of 2/3 is going to be parallel to this line. How it is. The relationship for perpendicular, this right here, this upside down capital T is for perpendicular, is called, it has the negative reciprocal, and I cannot spell RECP something, right? The negative reciprocal. What that means is you're going to take the fraction and flip it upside down, and you're going to change the sign. So this is a positive 2/3. So to change the sign, I want to make it a negative. And then when I flip it upside down, 2/3 becomes 3/2. So my perpendicular slope, here's my negative, because I went from positive to negative, because we want to do the opposite. This negative means opposite sign. And then the reciprocal means you just flip this upside down, which is 3/2. Okay, so there's my slopes, my parallel and perpendicular slopes. Now the thing is to find the equation of the line. Well, what I show my kids in school, there's actually two ways to do it. A proper math way, and then a way that most of everybody else understands. I'm not going to show the proper math way because it involves memorizing another formula and everything else. And both will yield you the same answer. I'm going to use the same formula, y equals mx plus b. So we're going to do the parallel one right here, and we're going to use y equals mx plus b. What's nice in this point, I have an x value and I have a y value. And I also know an m value. So I have an equation with a y, an m, and an x. The only thing I don't know is my b. Well, if I plug all those numbers in here, I can solve for b, and now I know b. So my y is 0 from here, equals my parallel slope is 2/3, times my x value, which is 3, plus b. All right, from there we just simply solve for b. We're going to get 0 equals 2 plus b, because this 3 and this 3 cancel and become a 1. I'm going to subtract 2 from both sides, and I got b equals -2. All right, so now I have a m, a y, an x, and a b. All I need to do is figure out how to write the equation. Well, my original equation has a y, and always has a y in it, and always has an x, and an m and a b. So if I knew the m and a b, I just put the numbers in and I'm done, and that's all I'm going to do. My y equals, my m is still 2/3. Here's the x, that has to stay. So your equation has to have this y and it has to have this x in it. And then my b is a -2, so you can do plus a -2 or just write -2. So there's my parallel line. That goes through the point 3, 0. And is parallel to y equals 2/3 x plus 1. Okay, so for perpendicular. All right, so where I got 0 equals 2 plus b is I plugged in my. So you're good here on this step. 2/3 times 3 is 2. It's arithmetic. 2/3 times 3 is just 2, and that's where I got my 0 equals 2 plus b. I cancel my 3's. All right. Okay. So there's my parallel line. So perpendicular, we're going to do the same thing. It's going to be a little quicker explanation, but for my perpendicular, I'm still using the y equals mx plus b. I'm going to use all the exact same numbers, but my slope is going to change. My slope is now going to be a -3/2. So I'm going to do 0 equals a -3/2 times my 3 plus b. Let's see, this is multiplying fraction straight across, so I've got 0 equals a -9/2 plus b. We add 9/2 over. I'm going to come over here. So we're going to add it, and we're going to get 9/2, because we're going to add 9/2 to both sides. My negative becomes a positive, equals b. So my perpendicular is going to be y equals my slope of -3/2x. In this case, it's a positive, so we do plus 9/2, and there's my perpendicular slope. So that's actually how you do every one of these problems. That is how you do every last one of these problems. They're all exactly the same. And no, Jad, 0 divided by 0, no, that's an indeterminate form, and you learn how to deal with that in calculus. Those are special forms. So that's the way I show it. If you want to see it the other way, I could show you the other way, but that requires memorizing the point-slope form and then using the point-slope form with a lot more algebra in it. This way is by far the simplest form. I didn't learn this way of solving until I taught at the high school under Miss Brewer.
She got how to do the parallels.
Perpendicular is the exact same. Yeah, I was running out of room. So what I'll do is I'll jump down to number 2 and I will do just the perpendicular part. Let me finish erasing. Boy. Glass. The more and more I use it, the harder and harder it is to erase.
Also branding markers.
Good enough. All right. Purple didn't like to come off. You know what? I haven't used yellow. All right, number 2. We've got y equals a negative 1/2 x plus 2, and my point P is 4, 1. Okay, so you're okay with the parallel. So my slope here, that's the key to figuring it out. My slope for this equation is negative 1/2. The key to perpendicular is take this slope, change the sign. I've got a negative. If I change it, it becomes a positive. So my perpendicular slope, negative turns into a positive, so I don't need to write it. But I'm going to write it anyway. And then I'm going to take the reciprocal. I'm going to take this fraction and flip it upside down. So I have 1/2. If I put my 2 on top and my 1 on bottom, I get 2 over 1. Well, we never write a fraction like this. Anything over 1, we just simply write it as the number itself. So this becomes a positive we don't write. It just has a slope of 2. Because I take this, I change the sign, and I flip it upside down. All right. From here, all you're going to do is use the equation y equals mx plus b. I have my m for my perpendicular. That's 2. I have my x right here, and I have my y right here. So this is x, this is y. I'm going to plug them into this equation. That's it. So I'm going to get my y is 1 equals my perpendicular slope is 2 times my x, which is 4, plus b. So I got my 1 from my y, my 2 from my perpendicular slope, which I took the negative, I changed the sign, and I flipped the fraction upside down. And I got my x here. From here, I just simply solve for b. I got 1 equals, well, 2 times 4 is 8 plus b. Subtract 8 from both sides, and I have negative 7 equals b. So now when we write the equation, we still use this form, y equals mx plus b. My y has to stay and my x has to stay. They have to be in my equation. So the only thing I fill in is my m and my b. Well, I know my m from right here, and I know my b from right here. So I could say y equals, my m is 2, then we'll write a plus my negative 7, but we never write a plus a negative number. We just write subtraction. So the actual equation is 2x minus 7. Oh, why? Well, this right here, this equal part, implies that this comes down. So that's how you do perpendicular. The only difference between how you find the parallel and perpendicular lines is the slope. The key to this is parallel slopes are the same that you have right here. And perpendicular, you change the sign. If it's positive, it goes negative. If it's negative, it goes positive. And you take the fraction and you flip it upside down. That's the only difference. Yeah. I know it's glitchy. I have to figure it out. I don't really want to go in and mess with my drivers, but that's the only way to fix the glitch. Gotcha. I didn't write the times when I started those. I can go back and look at those. Oh, that yellow comes off nice and pretty. Doesn't show yellow though. It shows green. I think it's because there's still some lead in the glass.
White. Clear. That's when it's completely.
Yeah. Oh. Oh, goodness. Oh, that's on the glass.
Yeah.
That's definitely. I think just, I don't know. Glass is getting harder and harder to clean the more and more I use it. What other questions? That pretty much covers geometry. Because every single question is like that. Just work it over and over and over again. This is more of a kill and drill type of exercise. You mad? Wow, there's 6 people on here. Well, 5 take you out. Any other questions? Tell you what, I got some emails from some Algebra 2 teachers, and they weren't real happy about 9, 10, and 11 on the new assignment. Wow, that's from a long time ago. There's not a B on number 2. So 2 is just a transformation question, not a B. You want me to do point B? Because there's not a letter B, it's a single question. That's right. So she wants point B.
Okay, cool.
So the first things first is we have to figure out the mapping on this. I give you B, point B is 6, 2. And that's going to map to something here. This is a vector bracket, not a 7. And that's going to map to B prime, which is 4, 5. And what it wants to know, what is this mapping? How did I turn 6 into 4? Well, this equation is going to be x plus some random number, and this is going to be y plus a different random number. So the question here is, what's A, what's B? Some of these you should be able to see pretty quick. 6 turns into 4 by subtracting 2, so A is going to be negative 2. But the way we'll actually set this up is I'm going to plug the 6 into the x. So I get 6 plus A equals this number here, which is 4. I subtract 6 from both sides, and I get A equals negative 2. So this part, this is negative 2. Do the same thing for y. I take this y, plug it in here. So I got 2 plus b equals, as you guess, this y value, which is 5. Subtract 2 from both sides, and I got b equals 3. So this becomes 3. So the mapping to this is going to be x minus 2, y plus 3. That's all the question's asking for, is what is the mapping. All 4 points are going to have the same mapping because these are what's called isometric transformations, meaning it doesn't change its shape. Kind of like this marker, when I move it up and down, it doesn't change its shape, it's just its location. That's an isometry or an isometric transformation. That's it. Big fancy word, isometric transformation. We're basically saying it doesn't change shapes, it just changes location. If it goes, so the X's is horizontal translations and the Y's are vertical. Yeah.
I get that.
Yeah. Oh. No, don't feel dumb. Question's a question. See if I can get coded.
Sometimes people complicate.
All the time, people overcomplicate math. It happens all the time. People think that's why math's hard, is because people overcomplicate it way too much. It is not connected. It looks like he's just going to sleep. For a large part, I have to get out of my head too when I work problems, so not to overcomplicate things. Parallel lines 4 and 6. Parallel lines cut by transversal. All right. Take a drink, dive into these. At least I can write the time on these so I can actually 22:30. All right, so on 4 we have something crazy looking like this. And this is kind of cutting through here. And they tell me that this big angle here is 135 degrees. And they tell me the inside angle right here, so right here, is 4x minus 3. Right there. It's kind of hard to see with that arrow, but even with my old eyes, I can still see it. Okay. Now, these lines are parallel. So these are same side interior angles. Same side interior angles are supplementary. Supplementary means if we add those two angles together, they equal 180 degrees. So if I add these two angles together, they should equal 180 degrees. So I just use that to set up my equation to find x. So I'm going to do 135 plus 4x minus 3 equals 180. So here's the first angle, here's the second angle. Add them together, because they are same side interior angles, they equal 180, which means they're supplementary. From there, this is just an algebra problem. So we're going to clean it up. 4x plus 132 equals 180. 4x equals, what does that become? 48. Divide by 4. X equals 12. Done. So this is just knowing the relationships between, are they parallel or are they perpendicular? Oh, did he just put that in there because somebody asked? Yeah, I had surgery to fix my cough, well, parts of my cough, and it got better, and then it's kind of come back. Yeah, allergy season hit, so the surgeon said I have to wait 6 months. Well, they recommend that I wait 6 months before I see an allergist. And I had the surgery done in December. So we're coming up on the 6-month mark. Then I can see an allergist to see exactly. So clearly, the surgery worked for part of it. But allergies is the second part. I have 3 different things that made me cough. I had surgery to fix one of them. Yeah, surgery to fix a cough. All right, so that was 25:17. I can just put the start times in the thing and it links it to the start time. That's cool. Your birthday's in September. What was the other one? 4 and 6. Okay. So this is more of a classic setup where you just have horizontal parallel lines. And then it's cut by a transversal, but they make it pretty extreme. They exaggerate it, but it doesn't need to be exaggerated. They tell you that this is 5x minus 11, and this is 24. You have no idea. I've coughed to where I almost pass out. I've coughed to where I've thrown up. And I've been coughing since my daughter was 2 or 3 years old. And she'll turn 21 this year. The positive of this is that because I'm always coughing, I have a strong core. Because my muscles are always contracting. So there's a positive to it. But I still have a big old belly. So it's not like actually exercising. All right. So last problem with same side interior angles. These are alternate interior angles. Alternate interior angles are congruent. Congruent in geometry, when we set our algebra equations up, set becomes an equal sign. So because I know these two angles are congruent, meaning they're the exact same thing, and in algebra, same means equal, I just set these equal to each other and solve. I have 5x minus 11 equals 24. That's it. This angle equals this angle. So same side, alternate interior angles are congruent. Congruent means that they're the same. From here, we just simply solve. We add 11 to both sides. We get 5x equals 35. Divide by 5. And x equals 7. Didn't even write the start time on this one. So about, well, basically, yeah, 25:17. So this would be about 25. I'll just put this is 5. All right, what else? What else? What else?
I'm gonna break the left.
I heard him getting mad.
He broke at me. You knocked the iPad. Hit you with
Is that what he's doing over there?
Yeah, because now
He wants to get petted.
besides
Oh, yeah. Nothing's more annoying than when he just walks right up to you and starts rubbing his head on your leg.
not beating. We'll have an hour.
Correct. If they're not, they're either congruent or supplementary. Those are the only two options. Either they're going to equal each other or you add them to equal 180. So what I taught my kids is to find the ones that are congruent. So if you know what are congruent, then if they're not congruent, they're supplementary. So it's either A or B. So it's pretty easy. If you just memorize, if you learn which ones are all congruent, you also then know which ones are all supplemental. If you know which ones are all supplemental, then you know which ones are all congruent. So it's just a quick, and there's only 4 angles that are congruent and only 4 combinations are supplementary. So not terribly bad. Well, there's more than that, but if you just get a general form, a general feel for it, you're good. My dog literally just walked up and licked my shin. Yeah, at least it's the one I could feel. Oh, the dog moved the camera. And he still is. More on that.
He slammed. He's gonna.
Coda, come here. Come here. Come here. He's walking to me all slow, like he's about to get in trouble. Come here. Pick you up so you quit causing chaos. There, happy?
He's a bad.
Wow, he's like yellow. Oh, it's like all of a sudden choppy. He needs a bad bath. Why is he so yellow? Is that just my lighting?
Why did we call him dingy?
No, that's like yellow. Look at me.
He's almost 15.
Is yellow his new gray? Because he's always been white.
He wants to.
What are you doing? Dirty. Get down. Go.
Oh, so for Pythagorean, can you do number 7A? I know it's easy, but I just need more time.
Yep. This is 31. Alright, so this is the converse of Pythagorean Theorem. I give you 3 distances and I ask you, is it a right triangle? 10, 11, and 14. I always say make A your smallest number, B your middle number, and C your largest number, because we're going to use the Pythagorean Theorem. A squared plus B squared equals C squared. So that's A, that's B, that's C. That's how I choose them. If you always do it in that order, you'll never mess this up. A is your smallest, B is your middle, C is your largest. C's always got to be the biggest. These two don't really matter, but if you do it in that order, you'll never mess it up. So from there, we just plug it in. 10 squared plus 11 squared equals 14 squared. This is 100 plus 121 plus 196.
Yeah.
I believe it's 196. Let me double check.
Yeah, because 225 is.
Yeah. 14 squared, yeah, is 196. You can clearly see that these are not going to equal each other. I got 221 equals 196. Ask yourself, true or false? That's really what you're asking. This is false. Therefore, since it's false, this will not make a right triangle. That's it. That's all it asks. Will not make a. Does it make a right triangle or does it not make a right triangle? Man, in school, the kids love the converse of Pythagorean Theorem. I don't think virtually anybody really ever missed that question when I asked it on a test.
Just do a.
Several students, they all want to do a video on that because everybody understood it. Oh, me too. That field trip was so great. Once we get through this, I want to email Crier, say, hey, let's start planning for next year.
So apparently.
Yeah, I think that's going to be the trend. We're going to do. I have a training this week on Teams, which I've already looked into, and I can use OBS as external encoder in Teams. So this way I can run my class straight off of this. Well, it's.
But then I got this week.
Pick up can finish it out?
Right.
Why would they do that? Because I was watching this special about the South Carolina women's basketball team this year. I didn't even know they were ranked #1 in the nation, and they won the national title last year. And they were, South Carolina, the Gamecocks.
Parallel and perpendicular.
Sure. I don't know why the video is going choppy in and out. I literally just upgraded it.
It's like,
but no, that's my computer.
I don't know.
No, I actually just plugged it in. Actually, that might be why it's a little choppy, because it's only like at 20%. Probably doing it like energy conservation. All right. Do you really want to do 10? 10 is ridiculous easy. Let's do 9. 10 is super duper easy. So 3502. So I'm going to do number 9 instead of 10 because 10 is just that fast. All right. So 9, I have y equals 1/3 x plus 1. I tried to pick a lot of these to give you nice pretty numbers. This one does not. 5 and -1. All right. So same thing. My parallel slope is going to be 1/3. It's the same as this right here. My perpendicular slope, I'm going to flip this upside down. So 3 over 1 just becomes 3. This is positive, so I change the sign to negative. So there's my perpendicular slope. What?
Nothing.
Oh. Okay. So from there, we use the equation y equals mx plus b. Here's my x, here's my y. We're going to plug them in. I've got -1 equal, let's do parallel first. Right, let's do parallel first. So we're going to do 1/3 times 5 plus b. So I have a -1 equals, now when we multiply our fractions, we multiply straight across. So 1 times 5 is 5, and 3 times 1 is 3 plus b. Now I'm going to subtract 5/3 from both sides. And we get -1 minus 5/3 equals b. Now we have to add and subtract fractions with different denominators. Well, 1 is easy. That's why I actually use the number 1, because it's easier to subtract fractions with. Just look at your denominator, and I can write -1 as -3 over 3, because 3 divided by 3 is your 1. Gives me a common denominator, minus 5 over 3 equals b. From here, this is -3 minus 5, which gives me a -8 over 3 equals b. So there is my b. So my parallel is going to be y, I don't need an equal sign there, y equals my slope of 1/3 minus my b, which is 8/3. Right at the very bottom of where I could write. Okay, so that one's way more complicated simply because of the adding and subtracting fraction with different denominators. That's about the most difficult. I can put this, once you understand it, I can only make it a little more difficult on the arithmetic. All right, so for my perpendicular slope, we're still going to use y equals mx plus b. From there, I have my x, I have my y, and I have my m, my perpendicular m. So I've got -1 equals -3 times my x, which is 5, plus b. From here, we just solve. -1 equals -15 plus b. Add 15 to both sides. And I've got b equals 14. Go back in, write my equation. My y stays. My slope, -3x, and then my b is plus 14. So this one was a lot easier than this one. It just really depends on the arithmetic. This arithmetic was more difficult. That's why this was the more difficult side to solve. The arithmetic here was easier. Hoorah. Y'all want me to show y'all how to, well, I'm just going to do it. I want to show you guys how I look at seeing and adding and subtracting fractions. It's amazingly frustrating to me when people say fractions are so hard, because fractions are not hard at all if you, see, there it is, choppy again. Fractions are not hard at all if you just, they're just not hard. I don't get why people struggle with this. So I'm going to do something a little weird here. I'm going to do 7 over 11 plus 24 over 16. No, let's not do that because I can reduce it. You know what? Yeah, let's do that. So in math, you've always had math teachers say simplify, simplify, simplify. But I don't think they ever told you why you simplify in math. You simplify math to make your next step of math simpler. Now, they always tell you to simplify at the end, which for me is, from being a math person, doesn't really make sense. because there's not another step. So why would you simplify when there's nothing else to do with it? You simplify during the problem to make the problems easier. If you're in my class, you see me do it all the time. I simplify and then I work the math. I simplify, then I work the math. I simplify, then I work the math. The only thing I really care about is you can't leave it as 2/4. You need to write that as 1/2 in my class. Just the real basic simplifications, which are just kind of standard across the board. So on this one, I look and see 7, 11. Both of those are prime numbers, so I leave it like so. I need to write that bigger so I have room to actually write with. So 7/11. But here, 24 and 16, they both have an 8 in common. 8 times 3 is 24, and 8 times 2 is 16. So I can actually add this, I can simplify this, simplify it by 8, and I'm going to get 3/2. Well, that looks a whole lot better than 24/16, especially for the next thing I want to show you. The way I show my kids to add and subtract fractions when they don't have a common denominator is multiply the bottoms. So when we multiply the bottoms, 11 times 2 becomes 22. That's going to be my denominator in the answer, in my final answer. Now, I'm going to multiply up like so. So it makes an X. I teach my kids this. This represents, my hands are the tips of the arrows. This represents multiplying the bottom, down like this. And then you bring your hands up. If you look, your hands are pointing in the direction the arrows are pointing. So I have kids on tests literally doing this when they're adding and subtracting fractions, and I don't care because they don't miss them. So now all we do is we just multiply going upward towards the arrow. 2 times 7 gives me 14. I'm going to bring my plus sign over here, and then 11 times 3 is 33. And now all I do is add my tops, and I've got 47/22. Now, if this fraction is simplified, I'd make them simplify it, but this one doesn't simplify, which is kind of odd from what I said before, because that's just kind of one of those things. Yeah, it's kind of like a drawbridge. I never thought of it that way, like a drawbridge. Here's your bridge here, and then it goes up like this. And that's always going to work out when you add and subtract fractions with different denominators. You don't do this with multiplying and dividing. You always do this when you add and subtract. Now, if they have common denominators, you can still do this and simplify, but if they have common denominators, you just add or subtract the tops and you're done. Those are easy enough. But when you have different denominators, it's just here and then here. I like the idea of a drawbridge. That's a great analogy. I've not had any students in 6 years point that out to me. I guess because there's no drawbridges around here.
Yeah.
None whatsoever. I think I've seen only 2 or 3 drawbridges in my entire life. If that. In real life. Not that we drive across.
What about when?
I think that's where we've seen them.
Okay.
So that's how you add and subtract. When you multiply, multiplying is easier. I'm going to use the same idea. We're going to do 7/11 times 3/2. You know what? I'm not going to use that one. I'm going to use one that we can simplify to show them the power of simplification. So adding and subtracting fractions, not hard at all. Once you do this for a little bit, you get this pattern, you get that pattern down, you just don't mess it up anymore. I'll come back to another example. No, so I don't need another example. Okay, so let me think of a problem here. Let's see. Even number, give me an even number. Just give me an odd number.
Right.
I prefer it to be smaller, and then I'll make the other side bigger. 9's not prime, 9's composite.
You said odd.
Oh, okay. 9. That works for me. All right. So I like 13 better than 9 because this there it goes again. It's.
Well, that's why I was like, how big? I didn't know if you wanted to keep it below 10.
13's fine. 13's fine. Otherwise, I'll use it. 13. times, let's see, let's do times 169 over, no, 54. Okay, now, in school, they teach you guys with fractions you multiply straight across. And then you're going to have to reduce. That's the hard way to do this one. I could do 6 times 169 and 13 times 54, get really big numbers, and then reduce. Not how I solve this problem. I don't solve this problem at all. Not like this at all. I actually simplify to make my next step of math simpler. My next step of math is to multiply fractions. So instead of, we're still going to multiply straight across. That rule doesn't change. However, when you deal with fractions, everybody knows that you can simplify top to bottom, right? And I'm going to be able to 9, 10, 16. This one does not simplify. This one does not simplify. So people are like, well, I'm just going to multiply straight across and see if I can simplify from there, which makes it more difficult. You can simplify on the diagonals. 6 and 54, if they have anything in common, I can take out. 13 and 169, if they have anything in common, I can take out. And if you're in my class, you see me do this all the time, and they really, my students struggle with this at the beginning of the year. I have to explain this over and over and over again. 13 goes into 169. Well, let's see, 13 divided by 13 is 1. 169 divided by 13 is 13. 6 goes into 54. Well, 6 divided by 6 is 1. 6 divided by 54 is 9. This gives me 1 times 13 over 9. Well, anytime you multiply anything by 1, you just get the answer back, and there's your answer in reduced form. That one's much simpler. Much, much simpler than doing 6 times 169 over 13 times 13 times 54, and then simplify. You would get the same answer, but if you simplify, you can see now your next step of math is much simpler. Now, it doesn't have to be, I set this up where it perfectly goes into it, but if we use the same thing, 6 over 13 times, well, I'm just going to leave that one alone. But let's say instead of it being divisible by 6, let's just do it divisible by 2 is 28. Okay, so in this case, we already know my dog, it's about feeding time for my dog, and he wants to get fed. We know 13, we know that this is going to reduce down like this. But now let's look at 6 and 28. 6 doesn't go evenly into 28. But do they have something in common? Well, 6 prime, the two prime numbers that make 6 are 2 and 3. So if I look, 28 doesn't have a 2 or a 3 as a prime number that can make it up. Well, 28 is not divisible by 3, but 2 is. So I can divide both of these by 2. So 6 divided by 2 becomes 3, and 28 divided by 2 becomes 14. This gives me 3 over 1 times 13 over 14. Well, then I multiply straight across. 3 times 13 is 39, and 1 times 14 is 14, and I'm done. So it doesn't have to be the whole number. It can be part of that number to actually multiply and simplify fractions. I know they show this in school. This video is so choppy right now. Throw them outside. You know, my code of conduct yesterday, my wife fed him around this time yesterday. That's why he's barking right now. He wants to eat.
You fed him late.
But then I didn't know she fed him, and she was gone. And then I fed him again about 8 o'clock. So he ate twice yesterday, but at 8 o'clock he was acting like he hadn't eaten, and I didn't know she fed him. So he's like looking at me, staring at me, barking at me, whining. So I figured he was hungry because I put him outside. He went outside, turned around, came right back in, scratched at the door. So he didn't have to go outside. And then, so I just thought he was hungry. So he got to eat twice yesterday. Yeah, I mean, remembering the steps, that's always the key with math, is trying to remember those algorithms. But this is one of those things. If you've been doing this since they taught you fractions, if you were taught fractions properly at the beginning, then by now it would be second nature because you will work hundreds and hundreds, if not 1,000+ problems. Yeah, unfortunately, my dog. Well, at least 2 of them are. I'll talk about Nala.
Oh, Nala's smart.
2 of them are. 2 of them are 3. I let my daughter figure out which one she thinks I don't think's the smart one.
Follows from the front.
Yeah, we have a dog that decides he wants to follow from the front. Yeah, just 2. One of them is a special. I don't know what to say about him. He's special.
He's a different boy.
He is different. That is for sure. The only dog I know that he will walk in front of you and constantly look to see where you're at behind him. He follows you from the front. He's special. Which is odd because he's a husky mix, and huskies are really smart. And he's smart enough to manipulate, but... Oh, he does. He punched her in the eye the other day. She thought she was going to get a black eye because she punched her in the eye.
Threatened her the day after.
I wish I could have seen that when he punched her in the eye. That would have been funny.
I know.
That's one of those moments you wish you catch on tape so you can laugh at her over and over and over again. Just play it on a loop and laugh at her. Yeah. So guys, if next week is the last week I have to turn, well, I've got to go put some package together for Algebra 2 and Geometry for next week. Rumor has it that that'll be the last week. That means next week will probably be my last week for streaming. I don't know. It's something with the processor right now.
She wants to know if you know the formula, the rate of interest, formula of rate.
Which one? So we have interest equals principal, rate, and time. This is simple interest. For compounding interest, we have your amount equals, I want to say it's 1 plus r divided by n over nt. I think this is compounding interest. Yeah, simple interest. This is for compound interest. And then we have principal. Oh, this would have been your amount equals PERT, and this is for continuous. I think that one's right. It's been a while since I've done that one. Are you looking it up? Compound interest. I think it's 1 plus r divided by n to the nth power. The I equals PRT.
So they have simple interest is PRT. And then there's compound interest. Then 1 plus r plus parentheses to the t minus p.
No, that one's... I wish I had my formula book here because I have it in my formula book. This needs to be your P right here. That's what I was forgetting. Compound. Oh yeah, I have the code. I'm pretty sure that's the right formula. Yep. And then P and E is a number like pi. It's an irrational number. What's PRT? Oh, what does the P, R, and T stand for? Yep. So let me erase the other ones. What class is that for? The only time I've seen this formula used, I wrote a formula book for the local junior college that we have here. And the only class I know that uses that formula was our very basic math contemporary class. I don't even teach this in high school because it's not really useful at all. but your P is your principal, which is your starting amount. That makes sense. Makes sense in the 8th grade. Your R is your interest rate in decimal form. And then your T is your time. T is time. If they give it to you, normally interest is compounded annually, especially with this one. It's compounded once a year, kind of like an annuity type deal. Once a year. Well, annuities are on a regular basis. So that's what, and then this is your interest. And that's how much interest you earn. So to give you an example, what interest would be if you have a principal of $1,200 at a rate of 5%, so that'd be 0.05, my percent, 0.05 over 5 years. So you would just take this, multiply it all out, and that would tell you what your interest is. So 1,200 times 0.05 times 5 gives you, your interest would be $300. You get interest back of $300, but in reality, nobody gets 5% at a bank. You're lucky to get like 0.01% or 0.02% or 0.5%, or that's a high one. Nobody gives like 5% or 7%. Interesting fact on the stock market, though, mutual funds generally, historically, when you're playing the long game, when investing is long game, gives about 6.5% to 7%. If you go back all the way back into the 70s and run historical analysis. Now, granted, that means when you put money in, you may lose money for 10 years straight or 5 years straight. But in the long run, over 20 years, over 30 years, you would get about 7% back. Much easier to do it when it's younger. I wish I would have known all this stuff when I was younger. Mm-hmm. Man, I wish I would have known all this stuff when I was younger.
That's why they always say, like, when you're younger,
that's why all those
stocks,
commercials.
you do it aggressively.
Yeah.
Like in the beginning.
Because it doesn't hurt you if you lose a bunch on aggressive stocks.
Exactly. When you're younger.
Oh, it cuts it off.
Yeah.
So to find the rate. All right, so rate would be a little different on this one. You'd have to manipulate this equation. So in math, we love giving you just one equation and then ask you a bunch of different ways, and we just use algebra to solve, right?
Mutual fund.
I mean, those are safe things to do. Bonds probably aren't the best thing to do right now, but bonds are probably not the best thing to do. All right, so if you want to do your rate, let's just say I got, I don't know, give me a number. $400 in interest. Give me an amount to start with. $1,550. You invested $1,550, and we're going to say over 9 years. So this is my T, this is my P, this is my R, and then my I. And I'm looking for R. I'm looking for what interest rate. What interest rate will give me $400 if I invest $1,550 in 9 years? Well, we've got to clean this up first. 400 equals 2,1,550 times 9, 13,950. 13,950. R, divide both sides, and I get 400 divided by 13,950 equals R, which will give me a decimal. 0.0286 roughly is approximately your R. Convert that to a percent, means you're going to move your decimal 2 places, and you get 2.8 So to get $400 on $1,550 over 9 years, you have to have about 2.86%. So it just depends. If they give you 3 bits of information, you just use algebra to solve for whichever one. And in 8th grade, it could be any of those. Believe it or not, they do algebra in 8th grade. 3%, Jad, you'll be way off. You want to at least do like 2 decimal places. Huh? Yeah. All right, guys. It's been an hour. I'm going to log off. I will be back up at 5 if you have questions tomorrow. Central Standard Time here in the United States. If you have any questions, I'll be back up at 5. I will see you then.